Okay, so as I was saying, today we're going to discuss GARCH model. This is to model volatility. So far, we have discussed yung ARIMA modeling. Usually, you look at the, sa finance, guys, ang tinitingnan natin, when you're modeling the returns, for example, we use ARIMA, autoregressive integrated moving average. Sometimes the ARIMA model will not be sufficient, especially for models where you have high volatility. Kaya nga si Engel at si Bollerslev, Nobel Prize winners to, they came up with a model in 1980 yata si Engel, and 1970 yata si Engel, 1980 si Bollerslev. Bollerslev was a student of Engel. Si Engel ang nag-develop ng ARCH model. ARCH means autoregressive conditional heteroscedasticity. Si Bollerslev, yung student niya, in-expand niya to para magkaroon ng GARCH model. Generalized autoregressive conditional heteroscedasticity. So ang minomodel nito, guys, yung volatility. Okay, which we said na kapag hindi constant yung variance o yung volatility, then heteroscedastic yung residuals natin. And hindi acceptable, guys, kung yung residuals natin hindi siya homoscedastic. So yung extension nito is not only to model the returns, okay, but also to model yung volatility. Hence we have this GARCH. Now, ilang beses na ako, guys, nag-advisor sa mga thesis ng mga students sa FIN. Tapos maraming beses na GARCH model yung dinidevelop nila. So I hope malaking tulong tong discussion natin. Now I also sent another RMD file, itong quant mod. So very briefly before we go to GARCH modeling, tingnan natin sandali itong quant mod, guys. Kasi this is a very important package for FIN students. No? Kasi it allows you to download data, tapos get and do some computations. Okay, so let's use this first. Can you see, guys, the screen on the quantmod.rmd? Pakichat na lang, please, kung nakikita nyo before I proceed. Okay. Thank you. Iba? Okay, thank you. Good. All right. So let's run this, guys. If you haven't installed, I think install nyo na si QuantMod. Ito yung sa technical analysis to, no? TTR. This is also a package na importante for technical analysis. Are you done with FinInve, guys, or Inve MFI? Are you taking it now or tapos na ba kayo doon? Kay usually si Mr. Chan pa yung nagtuturo nun.
Sir, ngayon pa lang po tinitake.
Ngayon kinukuha nyo. So are you doing some technical analysis?
Meron po, sir, yung DNL analysis po.
Okay, so sayang sa huli na natin diniscuss to, no? Pero I think may i-offer na elective kung i-consider nyo, guys, yung elective next term, yung FinMode, it's financial modeling. It will be all about R, okay, gagamitin si R, tapos modeling in finance, no? So kung kunin nyo yun, guys, may advantage na kayo kasi medyo may alam na kayo sa R ng konti. And it will be purely applied finance na using R. And ang pinakabida natin doon si QuantMod, no, na package. Sige, pakiran muna, guys, itong if you haven't installed this, you know what to do, yung install that packages, si QuantMod at saka si TTR. So I have already installed this, so I'll just run this. Very quickly, guys, before we go to GARCH. All right. So sabi dyan na linaload din niya si XTS time series to. Kailangan yun for quant mode. Okay. So okay na, no? So the advantage, guys, of using quant mode is you can directly download prices. So for example, itong function na to, this is from quant mode, yung get symbols. Okay, you can download data from Google, from Yahoo, from Fed, yung Federal Reserve ng US, and then from Wanda, kaso may nagkakaproblema dito sa Wanda, at saka sa Google, no? So this is the generic code. So tingnan muna natin itong una, AABA is Alibaba. It used to be Yahoo, no? Kaso na-acquire siya ng Alibaba. So tingnan natin, alphabet, enter. So nagkakaproblema, guys, sa Google. Ibig sabihin, before this used to work yung search engine as Google, then you can download Kaso parang kinat na ni Google yung Google Finance yung pagbigay ng data as of March 2018. So we'll just use Yahoo. Si Yahoo dati guys nagka-problema din, pero binalik na nila. So okay na to. So if we let's say if we get data, Google to, no? This is the ticker symbol, and then we specified na from Yahoo kunin Yahoo Finance. By the way, guys, kung hindi natin ilagay ito, ang default yan will be Yahoo Finance. So may Google na tayo na object dito. I'll click this. Okay, so you can see here, dinownload yung mga stock prices. Yung open, yung high, tawag natin dito, di ba, OHLC. Familiar ba kayo doon? Na-discuss ba yun sa technical analysis nyo? Open, high, low, close. Okay, this is OHLC. And then you have the volume, and then you have the adjusted value. Okay, clear so far, guys? Okay, then we can get this from Fred naman. This is Federal Reserve data. Yung foreign exchange anong country ba ito? Wait, check ko lang FX. Okay, so we have DEXJPUS. Sorry, hindi ko na-check kung kumuha lang ako ng exchange rate. Paki-check na lang, guys, kung ano exchange rate to, no? Deutsche ba to at saka Japanese, Japanese yan. I'm not so sure. Paki-check na lang, guys, kung ano yung exchange rate na yan. Then we also have this one from Wanda. Makakakuha din tayo ng exchange rate dito, pero this is not working now, no? Dati nag-work to So ganun pa rin, no? I will have to check kung bakit siya hindi kasi nagbabago-bago sila, minsan nakukuha ni quant mode, minsan hindi. So you can do this for several prices. Si Yahoo, si Google, Amazon. Tapos ito S&P 500, yung index. Let's try to get this sets of data from using quant mode. Run natin to. Tingnan natin kung ano yung mga mag-run. Okay, si AABA, nag-fail siya. Okay, ang umokay, guys, si Google, si Amazon, si Microsoft, at saka si S&P 500. GSPC, yung may caret, that's for S&P 500. Okay, except for AABA. Okay? So tingnan nyo, may mga na tayo dito, may mga objects, no? So for example, if I click Microsoft, ayan, yun din, no? Open, high, low, close, the volume, and then the adjusted figure. Si GSPC, that's your Standard & Poor's 500. Okay. All right, then what's good about quant mode, guys? Pwede tayong mag-chart, no? I-chart natin si Google. Okay, you can use bar charts, etc. Okay. So this is a bar chart for Google. Okay, by the way, guys, nung dinownload natin siya, click na natin to. It's up to the current, no? So hanggang 26 as of yesterday. Okay, from the start, which is January 3, 2007, hanggang current. So, dina-download niya. No? Okay, pati si Microsoft, 1, 3, etc. Okay, clear so far, guys? Paki-yes nga kung may questions. Let's continue natin to. Sasabi lang siya ng konting warning dito. Okay, but what's important for us is yung bar chart na to. Hindi lang natin siya masyado makita kasi ano, no? Kasi this is a long series daily to. Okay, but let's fix this. And we can also request that it be a candle chart. Tapos multicolored siya with theme white, yung background yan. So if we run this, yan, so black and white background. Okay? Hindi lang siya nagko-colored, I wonder why. Dapat ano to eh, dapat makikita natin na multicolor siya. If we run this sa console, sometimes guys, I prefer running this sa console kasi na-adjust ko yung size. I'll run it in the console. Tapos dito sa plots, no? So run natin, Control Enter. Yan. So mas kita siya. No? Then we can actually export this and save it as an image. Then you can play around with the chart. Okay. All right. So ito, Yahoo, subukan natin to ha. Get a set symbol to, no? Ito, we're specifying the parameters. Kaso magkaka-error tayo dito kasi hindi pa natin na ano si Yahoo. Okay, so pag sinet up natin, set symbol, ibig sabihin guys, this will be saved for future sessions. Masi-save natin to for future sessions. So let's leave that. Tingnan natin to. Some examples. Gamitin natin si Goldman Sachs, no? GS, Goldman Sachs. Okay, so andyan si Goldman Sachs. Again guys, pag clinic natin to, andyan na-download yung mga prices. So this is from January 1, 2007 hanggang most current, which is kahapon. No? Okay, then we know that it has an open, high, low, close. So pag rinan natin to is.ohlc, true. Ibig sabihin yung data natin, which we downloaded from Yahoo, yung Goldman Sachs, meron yung data na open, high, low, close. And then does it have volume? Okay. Has volume, true then, alam natin yan. Then if we want just to open the open column, OP, GS, so ang ibubuksan lang niya yung open. No? Or the adjusted lang. Okay? And then we can ask, saan ba dito yung yung highest point ng price ni GS? Okay, then sasabihin sa atin, ang highest niya is January 14. January 14, 2021, where the price was 307 and the adjusted was 307. Ang lowest naman niya was on November 21, 2008. The adjusted price was only 44.75. So we can check this guys. Pag print up natin yung series na yan. So dito yung highest. So dito yung lowest natin banda. No? So nakuha natin kung ano yung lowest at saka yung highest. Okay. Okay, so I have some notes here. So kunyari dito guys, we can actually, sinabi ko dito, ano, one would like to see what's happening within an observation or across a period of observations. Kunyari gusto natin makuha yung change in prices for one period or over many periods. So we can combine yung open at saka close and get the daily percent change from open to close. So i-run natin to. So you'll see here, no? Opening and closing, ito yung ano, yung percentage change. So this is the closing of the day 2 divided by the closing of day 1, no? Minus 1. So that's your percentage change. Pwede rin open to open, no? So ito naman ang kino-compare natin, yung opening ng day 2 at saka opening ng day 1. Okay, so and others, no? Percentage change from high to close. Saan na siya? Okay, nag-error ako. Bakit kaya? Hindi, sorry. May mali ako sa code, guys. Ha? High, close. Bakit may adjusted dito? Mali to, guys. Paki-delete to. High, close lang dapat. No? Yan, okay? Percentage naman ng, ng highest close. Okay, so there are others here. Okay, I just wanted to introduce this to you guys. Na it's a very powerful tool, yung quant mode. I would suggest that you study this more, study this package. Pwede rin natin kunyari kunin lang yung CGS 2007 lang. Okay, so ito, binibigay lang sa atin yung data na 2007 lang. You take a look at that. 2007 lang siya. Okay, ibig sabihin guys, pwede nating ma-subset, ma-filter yung mga data natin. Okay, ito 2008 lang. Ito monthly lang guys. 2008. Tingnan natin to ha. So what happens here? Okay. 2008 January, so January lang siya. No? Lahat ng January lang. Okay, then you can, of course, you can do a range from June 2007 to hanggang January 1, January 12. Okay, then same thing, 2008 hanggang pataas. Ito naman lahat, no? Or pareho lang yan na GS lang din. And pwede siyang non-contiguous. Kunyari, tatlong let's say sa month ng January 2020, month ng February, at saka month ng December. So you're only identifying the months. Okay, so ito yun. No? Alright, so I'll leave these guys to you, no? For your perusal. So my line chart, my candle chart, ang suggestion ko guys, tingnan nyo to. Ano naman siya, easily, I made it in such a way that madali yung maintindihan. Okay? But that's not really our focus today. That's not really our intent today. Our intent is really yung GARCH model natin. So i-close ko muna itong mga to. So we're doing now GARCH. And then nag-send ako ng isang notes sa Word file. Okay. So may some notes lang dito, guys. Hindi ko na save yung yung okay. I'll just send the modified file. Kulang ng simulato, no? Iba yung na-save ko, hindi ko na-save yung meron pang dapat notes before this. Sige. So anyway, let's move on to R again. Okay, can you see the screen, guys, ang R? Yung GARCH 1 model January 27 class? Okay, thank you. All right, so we need this packages: Quant Mode, XTS, Performance Analytics. Are you GARCH? This will be the first time I think we're going to use this. This is for GARCH. So if you haven't installed this, guys, kindly install this. Performance Analytics, I think we have installed this before. Okay, so I'll give you 1 minute, guys, to install if you haven't installed, and then we require these packages. Okay, so what I'm going to do is I'm going to remove this. Tanggalin natin lahat ng mga andito. So rm list is equal to last screen. Okay, so this is the code to remove the objects here. Remove, no? So that will remove everything here. Para fresh tayo dito. Okay, so let's move on. Okay, let's download let's use Apple. Let's model Apple. So here, from quant mode, get symbols, diba? Ang ticker symbol is AAPL. And then let's identify, let's set the period from January 1, 2008 to end ng 2020. 2020, December 31. So let's run this. So andyan na si Apple, no? Let's view Apple. So you can see it's from January 2, 2008 hanggang until December 30, 2020. Okay, walang trading siguro nung 12/31. All right? So we have this data. We're going to model this using GARCH. Let's see kung anong class yung object. So it's an extensible time series. Zoo is also time series, no? So okay tayo kasi pag nagmo-model tayo ng time series, dapat dapat time series yung classification niya. So let's plot Apple chart series. This is from the quant mode package. Okay, so ito yung plot ni Apple from January 2008 up to December 2031. So if you notice, hindi siya stationary, di ba? So if you're just going to model the returns, well, kailangan natin, kasi prices pa lang to, dapat natin kunin natin yung returns, tapos i-plot ulit natin, tingnan natin kung kung stationary na siya. Kung hindi pa stationary, guys, anong gagawin? Let's say we have already computed for the returns, kasi prices pa lang to, and then we got the returns, kasi yun, usually, guys, ang minomodel yung returns, not the prices, no? So pag tinignan natin yung returns, which is just the value at time t minus time t minus 1. No? What do we do, guys, kung kung hindi pa stationary yung returns? Paki-chat lang, please. Ano gagawin natin, guys? ulitin ko yung question ha. So itong plot natin, actually prices yan. No? We don't work really on the prices. What we work on is to get the returns. Alam naman natin yung returns, pwedeng simple return yan, pwedeng log returns. In this case, we're just going to use simple returns, which is just the value at time t divided by the value at time t minus 1 and then minus 1. Yun ang simple returns. No? So you're going to generate another set of time series, yung returns ni Apple. And then after that, i-plot ulit natin yung returns ni Apple. Tapos pag nakita natin na may trend pa, non-constant mean, tapos non-constant yung variance, no? What do we do? Anong remedy natin, guys? Kung may trend, for example. Anyone? What's the remedy, guys, kung hindi stationary? Ibig sabihin may trend yung may trend o may seasonality. Anong gagawin natin para ma-detrend siya? Mawala yung trend o para maging stationary siya? Any guess, guys? Hello, diyan pa kayo? Anong ginagawa natin? Okay, ang ginagawa natin, guys, dinidifference natin, di ba? Dinidifference natin yung time series. Dinidifference natin para mawala yung trend. Okay, so let's do this. Okay, let's first compute for the returns. Making use of the performance analytics, you can easily compute for the returns of Apple. So let's create an object called AAPL return, and then we're using performance analytics, and then the function is calculate returns. Okay, ang kinakalculate natin, guys, yung returns using the adjusted, not the closing. Okay, there are reasons why we use the adjusted close kasi yung adjusted close ang mas tama na market value at the end of the period. Okay, that's why that's the one that's being modeled. Okay, so we have now this object. Okay, ito na yung returns natin. We have this object AAPL ret. Okay, and then what do you notice, guys? Yung object na to, okay, meron siyang NA. Yung first row. Kasi nga, it's January 3 divided by January 2 minus 1. Yun ang formula ng returns. Tapos walang value tong si January 2 kasi wala siyang previous value. Okay, so what we need is just, ang kailangan natin, so let's remove this. Remove natin to. You have this Apple return, tapos remove so, row 1. Wala tayong comma dito kasi isa lang naman yung column natin. No? We only have one column here. So, let's do that. Okay, so tingnan natin yung Apple return natin. So wala na yung NA dito, no? Natanggal na. Then let's plot a histogram of Apple return. Before that, i-chart muna natin. Chart series. Tingnan natin si AAPL ret. Plot muna natin siya. Okay. So if you take a look, guys, yung Apple return na series, it looks like wala na siyang trend, no? So no need to difference this. Kung nag-aarima tayo, guys, tapos ang minomodel natin sa Apple return, hindi na natin kailangan i-difference to kasi wala na naman siyang trend, no? May problema lang tayo dito sa mga sa mga volatility. May volatility clustering tayo, no? Itong mga points na to. Ibig sabihin ng volatility clustering, pag tumaas yung stock price, ang tendency niya tataas siya ng tataas. Pag bumaba siya, baba siya ng baba. And it results into a clustering of volatility like this. Okay? So, pag nag-arima lang tayo, guys, magkakaproblema tayo sa heteroscedasticity ng error terms natin. So if you're just going to model this using ARIMA, you will have problem with the heteroscedasticity. Yeah, I won't discuss anymore the modeling of ARIMA for this kasi na-discuss natin ARIMA, but you can try na i-model nyo muna siya using ARIMA and then i-test nyo yung heteroscedasticity ng error terms and you'll see that heteroscedastic yung error terms natin. Kaya ang ginagawa sa mga ganito guys, you not only model the returns, you also model the volatility. Ito minomodel din to. And that's where GARCH arch comes in. So tingnan muna natin dito guys. So histogram nito, para makita natin guys kung normally distributed. Okay, parang mukhang normally distributed naman siya, no? Yung apple return. Kaso hindi natin basta-basta makikita dyan. So let's plot. Maglagay tayo guys ng let's plot. So ito chart that histogram. Ano i-chart natin yung apple returns. Then magdagdag tayo ng density. Okay, yung density guys yun yung curve. Tapos mag-add din tayo ng normal distribution. Then yung color nito, yung blue will be yung histogram ng apple red kasi histogram to. Yung green will be the density function. And then the red will be the normal distribution. Let's copy this here. Dito natin i-plot siya sa console. Para mas kita natin dito. Okay. So this is now our histogram. No? Okay. So yung blue dito guys, it's the histogram of the apple returns. No? Mukhang ano naman siya, mukhang normally distributed. Kaso, mas makikita natin yan kung overlaid siya with the normal distribution ng red. Yung green dito, that's the density function ng apple returns. No? Now take note that the apple returns is mas mataas yung ano niya, no, yung peak niya. Okay? Kaysa dun sa normal distribution. And that would indicate pag masyado yung peak niya guys, that would indicate some tails. So i-zoom nga natin to. Okay, so kita nyo dito guys, no? So medyo may mga tails tayo. Tapos yung mga tails natin, mas marami dito sa negative. Mas mahaba dito sa negative. So the mere fact that it's more peak than the normal distribution indicates that it has tails. And here, medyo mas maraming negative, no? Negative returns kaysa sa positive returns. Kuha niyo yun guys. Clear ba tayo? Paki-chat nga kung yes or no. Kasi importante guys yung histogram, importante yung plot na to para malaman natin kung paano natin i-model yung GARCH. That's why we did this. No? Kita nyo naman dito, mas yung mga negative na standard deviations. Ibig sabihin, maraming ng negative returns natin. Okay, let me pause. So far ba guys, okay tayo? Kung pwede, paki-chat. Questions? Paki-ano na lang kung clear so far. No? Thank you, Ryzen. Yung iba, I would appreciate guys feedback from you. Wawalo na lang tayo dito kung pwede sana yung iba mag-chat. No? Thank you, Kat. Thank you. Angelo, thank you. Okay, the rest, walang question. Okay, Jillian, thank you. Okay. All right. Okay, so we did this already a while ago, kanina pala, no? Print natin tong apple returns. So, sinagutan natin yung question na to. kung yung returns ba ng Apple, is it stationary? Yes, it looks like it's stationary. So constant yung mean natin. However, we might have a problem with constant in variance. No? Kasi mukhang may mga ano dito, may mga clustering ng mga variances. In other words, pag tumingin tayo dito sa area na to, iba na yung standard deviation niya, iba na yung variance niya. So possibly, guys, na hindi constant yung variance natin. So pag ganito mga cases, guys, kung nakikita natin maraming volatility clustering, the ARIMA model might not be the best choice. Okay? So mas maganda yata kung not only yung returns ang i-model, pati yung volatility. Okay? As I said a while ago, so far, dun sa past 4 terms, tatlo doon, guys, ang in-advise ko na all about volatility clustering. Okay. So, it's important first to look at volatility. How do we measure volatility? Volatility is measured by standard deviation. Okay, so sa 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 I'm not sure if this is quant mode yata to, check natin. Quant mode. Quant mode ba to or performance analytics? Check ko lang ha. Hindi siya quant mode, it's from performance analytics. Performance ito. Okay? Para alam lang na din natin, guys, kung saan galing yung function na to, SD. Okay, so here we're computing for the standard deviation of hindi. Saan siya galing? Baka sa XTS. Anyway, guys, sige. Hindi ko na ano. Baka sa XTS lang. XTS? XTS ba? Hindi pa rin. Hindi ko check, sorry ha. Anyway, guys, basta, i-run na lang natin to, no? Hindi ko alam kung saan siya galing. Baka sa base R lang. Ito kasi yung mga inano natin mga in-apply na packages, no? Okay, ang importante naman dito, guys, makompute natin standard deviation ni Apple returns. Okay. So, ang standard deviation na, guys, 2%, 0.02. So, since si Apple return daily yan, itong 0.02 na yan, daily, average daily standard deviation yan. But what we usually want to know is the annualized volatility. So how do you compute for the annualized volatility? Since there are approximately 252 trading days per year, so kinukuha natin yung standard deviation, yung daily to, and then i-multiply natin ang square root of 252 to get your annualized volatility. So let's get this. So ang daily volatility is 2%, ang annualized will be 32%, no? So average ng annualized volatility from the beginning of yung Apple rep, this is January 3, 2008 hanggang dulong-dulo. Okay, yung average yung volatility nun is 32%. Okay, now we can get also volatility ng particular years lang. So kunyari to, guys, standard deviation ng Apple rep only for 2008 annualized volatility. If you check this, tingnan nyo, guys, 58%. Ibig sabihin ng global financial crisis, grabe talaga yung volatility. Grabe yung extremes yung pagbabago ng ng returns, no? So dito 'yon, no? Dito sa area na to. So this most probably will still be 2008 pa rin to, no? So yan. So nung kinompute yung returns dyan, yung standard deviation ng returns, yung average standard deviation ng returns, then nakita na 58% siya. So ang laki compared to the annualized volatility for the whole period, kasama yung 2008 hanggang 2020. Kung titingnan natin, guys, si 2009, mas bumaba na siya, 33.9% lang. Vis-a-vis 2008, no, na 58%. Noong 2019, 26% lang, no? Mas mababa siya kaysa dun sa 2008 at saka 2009, no? Okay, pero no 2010, 2020 yung kasama na dito yung yung COVID, no? Tumaas din siya 46%. Okay? So I hope clear to guys. In order to get the annualized volatility, kukunin natin yung square root ng 252 multiplied by the standard deviation. So very convenient talaga guys dito sa sa R. Kitang-kita natin kagad, no? Okay, any questions? So the standard deviation over the complete sample can be substantially different from the standard deviation on subsamples. So nakita natin during the financial crisis, noong 2008, iba yung average volatility niya. It reached up to 2008, 58%. Pause muna ako. So far clear guys yung annualized volatility. I would appreciate some feedback from you. Clear ba guys? Pakiyas na lang. Thank you, Kat. Ryzen, thank you. Pakunti ng pakunti. Jillian, thank you. Yung iba hindi na sumasagot. Baka wala na sila. Okay. All right. So, thank you for those who are replying. Thank you, James. Okay, so we learned how to compute for the annualized volatility. Importante yan, guys. No? Tinitingnan natin yung volatility for the whole year of 2008, 2009. Nagko-compare natin, ako-compare natin na yung volatility which is measured by the standard deviation for 2008 was very high, 58%. No? So that was expected kasi global financial crisis yan. Although noong 2009, as far as Apple is concerned, medyo bumaba na yung volatility. Ibig sabihin na hindi naman siya masyadong yung mga changes sa returns. Pero bumalik ulit sa 2020. Okay, so now itong rolling monthly volatility, okay, dito na sa ano yan ito. So take a look at can you see the Word file? Kita ba guys yung Word file? May notes akong binigay sa inyo. I'll just post another kasi mukhang hindi ko na post yung kompleto kasi nagsimula to sa rolling volatility. So paano ba yung rolling volatility? Kunyari you're looking at the monthly volatility. So ang ginagawa niya yung first 22 days, no? So that will be the measure for volatility for this period. Tapos yung gagalaw na naman siya, magdadagdag ng isang araw, babawasan ng isang araw yung previous. So 22 days and 22 days. Tapos magko-compute ng volatility ng standard deviation. Okay? So that's what a rolling volatility is. So we can estimate actually volatility using the rolling volatility. Kaso nga lang may weakness tong method na to. But let's just compute this using R. Okay, again guys, sa performance analytics, we can have this chart ng rolling performance ng volatility. So here, ang inaano natin, ang object natin, yung returns, yung Apple returns, then this is from 2008 to 2020, okay? With is equal to 22, ibig sabihin monthly volatility to. Okay? Ang scale niya is annual, no? Ang function niya, annualized standard deviation. Then, dinidescribe lang natin ito Apple's monthly rolling volatility. And then for 3 months naman, guys, ang gagamitin natin na width is 66. Okay? So this is also from 2008 to 2020. And then for yearly, ang width nito, guys, 252. So this is Apple's yearly rolling volatility. Again, guys, how is this computed? So kunyari yung monthly, kukunin yung first 22 days, i-compute yung volatility nun. So that's 1. And then gagalaw na isang araw, tapos babawasan ng previous day, kukompute na naman yon. That's another standard deviation. No? So ipa-plot ngayon yan. So let's ask R to plot this. Partition natin yung plots natin, 3 rows and 1 column lang para magkakasabay ito. Okay, so siguro dito natin gawin guys. Copy natin yung code natin, Control C. Dito natin i-plot sa para mas malaki yung natin. Okay. And then Control Enter. one more, yung monthly, hintayin natin, yan. Okay? Okay, good. So export natin, pwede nyo ano to, save as image, yan. Okay, so very powerful ang R, ano, sa charting at saka sa ano. Okay? You'll, pag gagawin mo sa Excel yan, patay. Okay, tingnan nyo guys yung monthly rolling volatility. So 22 days to, no? So you notice na mas magalaw siya kasi nga mas maraming computation ang volatility nito. Ito naman 3 months, mas ano siya, mas sabihin natin mas less yung galaw kasi 22 days, 66 days to eh. Mas maliit to guys, itong annual, no? Kasi you're looking at 252 days. Kaya tingnan nyo, dito nagsimula to. Kasi first 252 days, kukompute niya. And then gagalaw siya ng gagalaw every 252 days. Okay? So notice na yung monthly volatility, siya yung may ups and downs talaga, no? So dito 2008 to, no? So talaga yung kita nyo dito, oh. Tapos dito naman yung sa 2020. Sa time na ng COVID to, kita nyo yung volatility dito. Okay? So kikita natin dito guys, hindi constant yung variance, no? Requirement yun guys for stationarity, no? Okay, so kita natin dito. Okay, any questions with this? So volatility, that's one way to measure volatility using rolling volatility. However guys, may weakness to kasi mahirap, pwede nating gamitin to tapos ifo-forecast, pero medyo may weakness to, no? Kasi ginagamit lang natin yung past observations niya. Okay, so that's why we need to we'll go to another method, yung GARCH nga, no? Pabalik tayo. So may notes lang ako dito sa rolling volatility natin. In the rolling charts, corresponding rolling, we see the corresponding rolling volatility estimates. The switches between periods of low and high volatility. Yun yung sinabi ko to kanina, no? However, in practice, guys, masyadong simplified to. A higher accuracy is achieved when we use the GARCH model. Okay, so, okay, before we go here, puntahan ko muna ulit yung Word. Can you see the Word file, guys? Pakichat nga kung kita yung Word file. Please. Okay, thank you. Alright, so itong Word file guys, ito sinabi ko na yung rolling window, no? Okay, now, let's take a look at this one. Okay, just to explain, paano ba tayo nag-GARCH analysis? So, a GARCH means, di ba, generalized autoregressive. Sulat ko nga yan. Generalized autoregressive conditional heteroscedasticity. Okay, sa ARIMA guys, ang minomodel natin yung returns. Sa GARCH, ang minomodel natin yung volatility. So that's the difference. Sa ARIMA, we cannot model the volatility. Lolo ko itong sorry. We just increase the size. So generalized autoregressive conditional heteroscedasticity. Yung ARCH guys, mawawala lang si generalized. Nauna si ARCH muna yung na-develop ni Engel, E-N-G-L-E, yung Nobel Prize winner sa economics. Tapos, inano lang siya, in-improve siya ni Bolerslev. Okay, kaya naging generalized. So, kailangan natin guys, yung returns, no? Yung returns ang tinitingnan natin, as I mentioned a while ago. Then, we can choose what we call an information set. So, kukunin natin yung returns of the previous periods. Okay? So r sub t minus 1, r sub t minus 2, etc. No? So ito yung returns natin at time t. Then we will get the returns at time t minus 1. Okay? And then guys, ano nangyayari? Okay, we can to estimate the average returns. Well, kukunin natin average nito. Average returns. So that's mu sub t is equal to expected value ng returns given yung information set natin. So that's how we mathematically show the symbolize yung average na mean. Okay, and then ang gagawin guys, makukuha natin error terms, no? Kasi ito, actual return minus average return, actual minus average, actual minus average, actual minus average. So you now have a series, you now have an object of errors, no? Yung difference ng actual return dun sa average. Okay? Alright? Then tapos dito guys, ang gagawin natin, kukunin natin yung variance nun. Diba? Alam natin guys, yung variance is sigma squared. So what we do is get the variance of the sigma squared. The variance of the return. So that's return minus actual minus mean squared. That's how we write it, which is your error squared. And then that's so that's what we get now the standard deviation, which is the square root of your variance. Okay. Sa rolling mean model guys, ang ginagawa lang natin, yung average mean is just the average of the sum of your returns. So inad lang natin yung returns natin, tapos dinivide natin kung ilang periods yun. Yun yung rolling mean model natin. Okay. To make those predictions in practice, we need an equation to replace the expectation in the formula. So dito na tayo papasok guys sa GARCH natin. Okay, so yung rolling variance model natin, ganun din. We just make use of the squared error terms. We just get the average of that. Now, iba guys si rolling variance model kaysa kay ARCH. So tingnan natin guys si ARCH, no? Anong kaibahan niya? So si rolling variance, kinuha lang natin yung mga error terms, tapos in-square natin, then we got the average to get the variance, no? Now to improve on that, ang sinabi ni Engel, mas maganda kung i-model natin si volatility, si variance by using this equation. So meron tayong constant plus, okay, take note, we will multiply yung error squared ng a certain factor alpha. Okay? So this is now what we call your ARCH model. So ito yung dinevelop ni Engel. Tapos ang nangyari dyan, in-improve ni it was shown that the GARCH model is a lot better than the ARCH model. Okay? So this is ARCH 1. Ang ARCH 1 guys, ang ginagamit lang natin, pag ARCH 1, one lag value. Okay, so it will become omega plus alpha times epsilon squared t minus 1. Yun ang ARCH 1 guys. Pag ARCH 2, then may t minus 2, t minus 2 error squared. Okay? Now, ang difference sa GARCH guys, so in-improve the Boller's-Lev si ARCH. So dalawa na yung parameters natin sa GARCH. Ang ginagamit natin ng predictors, hindi lang yung mean at saka hindi lang yung error squared, previous error squared, pati yung previous variance squared. Okay? So you notice now the difference between the ARCH model and the GARCH model. Si rolling variance model guys, ang ginagamit lang yung errors, ina-average lang siya. So parang equally weighted to, no? Equally weighted yung mga errors natin. But we know guys na mas nakaka-affect yung mga error terms na mas closer to the current value kaysa yung mga error terms na let's say 100 periods ago. Mas malayo yung effect nun kaysa dun sa mas close dun sa current value. That's why here guys, hindi natin kinukuha yung average. Ang kinukuha natin dito is may factor tayo na i-multiply dun sa most current na most current na past values ng error squared. Ganun din dito guys, no? So ang GARCH 1 model natin, 1 yung alpha natin, 1 yung beta natin dito. Yung 1 dito guys, ibig sabihin nun, log 1 ng error squared. Yung 1 dito naman, log 1 ng volatility squared. Okay? Pause ako guys. So clear ba so far? Clear ba so far yung difference ng ARCH at saka ng GARCH? Yung ARCH, yung mas lumang model yan, 1970s, I think 1972. Tapos after some years, nag-develop ni Bollers-Lev, no? He came up with the GARCH. I think he was working also with Engel. Okay, guys, paano naman please? Pa-chat naman kung clear so far. Pwede na ba ako mag-continue? Okay, thank you. Okay, sige. Alright, so gagawin natin guys, just some reminders dito, no? So pakibasa lang guys to itong mga notes dito. Para maging realistic si GARCH, guys, we need the following restrictions. Dapat si omega, so si omega ito yung average, si alpha at saka si beta dapat positive siya lagi. Hindi pwedeng maging negative yung isa dito. Okay? Dapat dapat positive tong tatlo lagi para yung variance natin positive kasi hindi tayo pwede magka-negative variance. Tapos yung coefficient ng error squared natin at saka volatility, dapat yung alpha plus beta, dapat hindi siya lalampas sa 1 pag sinamap natin. Okay, ang reason yan, para guys, maging mean reverting siya. I'll explain what mean reverting. Ibig sabihin, babalik siya dun sa mean. Otherwise, kasi pag hindi siya bumalik sa mean, mag-e-explode yung time series natin. Aakyat ng aakyat yan o bababa ng bababa yan. Okay, the long run variance is determined by the value of omega divided by 1 minus alpha minus beta. Okay, so please remember these three. Okay, so ano ba yung normal na GARCH model natin? So this is called normal GARCH 1.1. Normal siya kasi ina-assume natin na yung returns natin normally distributed. Although kanina guys, nakita natin na hindi normally distributed yung yung returns natin. So papakita ko sa inyo in a while that kung i-model natin si normal or versus skewed, mas lalabas na mas maganda yung skewed model natin kaysa normal. So ano yung equations natin? GARCH 1.1. So pag nag-GARCH tayo guys, dalawang equations ang kailangan natin ibigay. No? Number 1, yung returns is equal to a certain constant plus error term. Ang assumption natin dito guys, yung error terms natin, yung difference between returns and the mean returns is normally distributed with zero mean and constant variance. And then this is now the model for your volatility, for your variance is equal to omega plus alpha squared residuals at saka yung squared volatility. No? Okay, so apat na parameters ang ibibigay sa atin ni R. Yung mean, yung omega, yung alpha at saka beta. Ang ginagamit dito guys sa method is maximum likelihood. Okay, it's a method guys na related siya sa OLS. Kaso dito sa MLE, ang ginagamit, magko-compute siya ng mga mean, itong apat na parameters na to, so that the GARCH model is most likely to have generated the observed return series. Para malapit siya dun sa value ng returns. Okay? So this is what we're going to do. No? Tatlong steps yan. Okay, I leave that for you to read. Dito na tayo pumunta sa R. Dito na natin gawin. Alright, so Okay, GARCH 11. Bakit GARCH 11, guys? Yung 1 will be the lag for the square error terms. Ito yung alpha. Yung 1 dito will be your beta, which is the coefficient for your volatility squared. Okay. So, ang gagawin natin muna, constant mean, tapos normal yung distribution ng returns. Okay, so ano ibig sabihin nito? Standard GARCH. Okay, ibig sabihin constant mean, ibig sabihin wala tayong ARMA, no? Wala tayong autoregressive, wala tayong moving average. We're not modeling the returns based on past values of itself and past error terms. Okay, I hope you remember this. So ang equation natin, yung kaninang pinakita ko, R is equal to omega plus your error term. Walang AR or MA component. And then, for the volatility, so yung variance model natin, we will use standard GARCH, which is 1, 1. And then for distribution, we will use normal distribution. Okay, so ang gagamitin natin dito, guys, yung R, itong RU GARCH, no? So this is R, and then U stands for univariate. Ang ibig sabihin ng univariate, guys, you're just using one time series. Kasi merong RM GARCH naman. Multivariate yun. Maraming time series na ang ginagamit natin. But for this, guys, RU GARCH lang tayo, no? Okay, so in order to model our GARCH, we have to identify, ito yung first part, U-GARCH spec, tapos ang pangalawa, U-GARCH fit, tapos ang pangatlo, U-GARCH forecast. So tatlo yan, guys, nasa Word file niyan, no? Yun yung kailangan na U-GARCH spec, U-GARCH fit, at saka U-GARCH forecast. Those are the three functions na dapat gawin natin. Okay, so let's start. Okay, for the U-GARCH spec, guys, okay, we're going to create an object called spec1. Tapos ilalagay natin dito yung tatlong parameters, no? Yung mean model natin, yung variance model natin, at saka yung distribution model natin. Ito yung tatlong kailangan natin. Okay, so first, yung mean model natin, sabi natin, constant lang muna siya. Ibig sabihin yung ARMA natin, ARMA order is equal to 0, 0. Okay, pag siniro natin si ARMA, ibig sabihin walang autoregressive terms ang gagamitin natin para i-model yung mean. Wala ring MA terms. If you recall, guys, ang ibig sabihin ng AR, we're going to use the past values of the returns. Okay, hindi natin gagamitin yon. Sabi ko nga, ang equation lang natin, ito lang, no? Return is equal to the mean plus the error term. So ito yung constant mean, guys. Kasi pag AR ang gagamitin natin, dapat meron yang RT-1, di ba? O pag MA, dapat may epsilon sub T-1. Okay, I hope clear yon, guys. Okay, so kailangan natin specify yan. Balik tayo dito. So list natin ng mean model is ARMA. ARMA order is equal to 0, 0. 0 yung AR model natin. 0 yung AR component. 0 yung MA component. In other words, guys, yung mean natin, yung R, will be modeled na walang past values niya at saka walang past error terms siya. Ano lang siya? Mu lang. Constant lang. Ito yung, guys, constant mean. Okay? Next, yung variance model natin. Okay, list natin model is equal to S-GARCH. Standard GARCH, guys. Ano ibig sabihin ng standard GARCH? 1, 1. Okay, ang standard GARCH, guys, is yung standard GARCH, which means, ano yun, yung GARCH 1, 1. Ibig sabihin nun, guys, may isang coefficient to measure yung error squared at time t-1, yung previous error squared at saka previous na volatility squared. Which is, babalikan ko lang ulit, guys, ito yon. Ito. Yan. So you see here, this is GARCH 1-1, no? Kasi one past value ng error squared, one past value ng volatility squared. So bibigyan tayo ng alpha, beta, bibigyan din tayo ng mu, at saka ng omega. 4 ng parameters ang ibibigay sa atin. Alright, so let's go back. Okay. After creating our spec 1, guys, yung UGARCH spec natin, i-create natin yung model natin. So this is mod 1, model 1. So kailangan natin to, yung function na to, UGARCH fit. Ito na yung mag-create ng model. Ito yung mag-create ng specification. Ito yung mag-create ng model. Okay, ang data natin is equal to, ang data na minomodel natin is Apple return, tapos ang specification is spec 1. Ito yun. So babasahin ni Arto, ito yung specification natin. Yun ang gagamitin niya para gumawa siya ng fit, model fit, and we're going to call it mod 1. Okay? Sige, run muna natin to, guys. Let's run this. Okay, so take note, guys, may spec 1 na tayo dito ng object. No? It's a UGARCH spec na, na object. Tapos mag-create tayo ng model 1, ito, using UGARCH fit for the Apple returns, and then the specification is spec 1. Run natin. Okay, so may model 1 na tayo, and then kunin natin values ng model 1. Mod 1. Yeah, so this is now our GARCH model. Okay, so GARCH model natin, standard GARCH, 1-1, ibig sabihin, 1 log ng error squared, 1 log ng volatility squared. Mean model natin is 0-0. Okay, AR, MA. Fee, I think fee is financial, so integrated siya, no? Hindi siya integrated. And then distribution yung normal. So ito na yung specifications natin, guys. No? Okay, then ito na yung model, guys. So it now gives us mu, omega, alpha, and beta. And all of them are significant. Yan. So we can now write our model, guys. Copy ko nga to. Control C. All right. So let's first write our model. No? Significant ba yung mga parameters natin? Di ba sabi ko, 4 yung ibibigay sa atin. Yung mu, yung omega, yung alpha, at saka yung beta. So are they significant? Are our parameters significant? Yes, significant sila. No? Ito, probability less than 0.05, 0.05, 0.05. Okay. So how do we now write our model? Yung mod 1 natin, diba? This is our first model. So we first write our model for our returns is equal to mu 0.002007 plus your error term. Yan. So this is your return model, constant mean plus the error term. And then the model now for your volatility. So it's equal to what, guys? Omega muna. So this is 0.00015 plus yung component ng, this is 0.12017 times the alpha is that's the coefficient of your error squared, no? And then plus 0.8412 times past volatility niya. One period kasi GARCH 1-1 yan. So this now comprises your GARCH 1-1 model. You have a model for your returns, you have a model for your volatility. Okay? And it's significant, no? Lahat siya significant. Ganun guys, ganun yung pag model ng GARCH. Okay, then let's take a look at some of the other outputs here. Okay, yung box test guys, this is a test for yung standardized residuals, ite-test natin kung may autocorrelation siya. Dapat guys, for our model to be okay, dapat walang autocorrelation or serial or collinearity or serial correlation yung error terms natin. So the null hypothesis is, what's our null hypothesis? No serial correlation. And you can see here that in lag 1, no, may lag 2 pa, may lag 4. Okay? Yung lag 1 natin, ibig sabihin yung relationship ng magkasunod na value is 0.4686, which means p-value is greater than 0.05. So we fail to reject the null hypothesis. So ano ibig sabihin nun? If we fail to reject this, ibig sabihin walang autocorrelation. So okay tayo guys. Okay tayo kahit lag 1, lag 2, lag 4. So okay yung model natin, yung GARCH model natin. Kasi walang serial autocorrelation. Then ito, ang check naman dito yung squared residuals. No? Standardized square residuals, ganun din. No? Ganun din. Okay yung natin, yung model natin, yung GARCH model natin. Okay, so kita natin dito yan. Okay, lag 3, lag 5, lag 7. Okay, walang serial autocorrelation. And then, dito sa last, guys, ito tingnan natin, ito, goodness of fit test. Goodness of fit test. Okay, ang null hypothesis natin dito is that yung distribution model natin which is yung normally distributed, di ba? So this is the test for the distribution model. So yung HO natin is the distribution model we used, which is the normal distribution, is okay. Now, if you take a look at the p-values, lahat siya, no? It's less than 0.05. So we reject that null hypothesis na okay yung normal distribution natin. So ibig sabihin nun, baka may mas maganda pang we can use another model. Wag yung normal distribution. Okay, so that's what that means. No? Okay. So itong answer na to guys, what are the coefficients? Ito yung omega natin, yung mu, omega, alpha, beta. Are they significant? Yes. Model for the return, sinulat natin kanina. Model for the volatility, sinulat natin kanina. And then may AIC tayo dito, yung Akaike Information Criterion. So we have here the Akaike. Ito, no? So saan ginagamit to guys? Ginagamit to in comparing it with other models. Okay, so we'll leave that as is muna. No? Okay, ano pa? Are the standardized residuals autocorrelated? No, sinagot natin kanina yan, no? Doon sa yung box test, di ba? Ito, no? Sa yung box test, yung standardized residuals, null hypothesis is no serial correlation. P-value is greater than 0.05. We fail to reject this. So walang serial correlation sa mga sa mga residuals natin. Wala ring standardized, wala ring serial correlation sa standardized square residuals. Okay, so that's the answer to that. Okay, ganun din. Based on 5 and 6, do they behave like white noise? Ibig sabihin ng white noise, guys, walang trend, walang seasonality. Yes, guys. Yung residuals, kasi walang autocorrelation eh. Pero, yung 5 and 6 ba natin, yung question 5 and 6 natin, does it indicate that our model is valid? Yes. Kasi walang autocorrelation. Pero sabi ko sa inyo guys, yung question number 9, dito tayo madadali sa goodness of fit test. Kasi we fail as far as the distribution model is concerned. Okay? Kaya kung i-plot natin to, okay, plot model 1. Okay, if you take a look at this guys, so yung plot na to, okay, merong pwedeng 12 na merong pwedeng 12 o 12 na plots na pwede nating magamit, no? Okay, let me just show them one at a time. Kung 1 guys, okay, kung 1, asan na si 1? 1, enter. Ayan. No? Hindi lumalabas dito. So, ito si 1, guys. So, this is plot 1. Okay, yung tagal niya, mag-ano. Dapat lalabasin dito yun. Okay, then, iba-ibang plots, guys, ng diagnostics dito. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we'll take a look at them one by one next sa Friday na lang kasi magda-time na. But if we can plot them all, guys, ito yun, no? If we want to plot them all, ito. Yan. So this will now plot everything for us, no? Yung 12. Tagal lang yan. Tagal, magalaw pa. Okay, so habang pinaplot siya, titingnan natin, guys, so ano yung meaning ng mga anong yan. Pwede din, next, guys, yung last. Kasi di ba, GARCH spec, GARCH fit, tapos yung huli, magpo-forecast tayo. Kasi ano ba importance ng GARCH model? Ginagamit talaga yan para mag-forecast. Tanggalin ko muna to. I-zero ko muna siya. Pag siniro kasi maka-cancel. At wala. 0. Control Enter. Ayan. Okay? Sa wakas, nag-load. Ayan, guys. I would have preferred it to be plotted here than dito sa console. Okay. Tingnan nyo, guys, to, no? Yung QQ plot natin, tingnan nyo, hindi siya meron tayong dito sa outliers, pinakita na natin ito kanina, no? So that's why hindi normally distributed yung data natin. Sa Friday, guys, i-discuss ko kung ano itong news impact curve at saka yung ibang plots dito. So rich information dito. And then last, guys, itong forecast. So I created an object called fcast1. Ang code, GARCH forecast. Model 1 yung fino-forecast natin. Then 20 days ahead. Okay, so i-plot natin to. Okay, bakit ganito, guys, yung plot ng natin, ng returns? Kasi di ba constant yung returns natin? 0.002. Naalala niyo yung model natin? Ito, 0.002. Diba? Kasi constant mean tayo. So yung return siya, ang forecast siya, ganoon pa rin. Constant yung mean natin, 0.002. And then, last, ito, plot. Okay. Omega. 20 days, guys. 20 days. Ano ibig sabihin nito? Ibig sabihin nito, over the next 20 days, tataas yung natin. Ang forecast natin sa variance natin, tataas yun. Ito yung plot niya. Okay, so that's the estimate or the forecast for your volatility for the next days. Okay, I'll leave this application, guys, next Friday na lang. Paki-check na lang ito, guys, no? Ito. Ang nabago lang dito, guys, hindi natin ginamit si normal. Ang gagamitin natin si skewed. So this is skewed SSTD, student distribution. Okay. Kung pwede, guys, pakisubukan to, tapos i-compare natin, paki-compare, guys, sa model 2, no? Para yun ang discussion natin next Friday. Okay, and then here, kung pwede, guys, tingnan nyo na rin. Ito hindi siya yung standard GARCH. GJR GARCH naman. Yung kay Gloston, Jagannathan, Rankel. Kasi may iba-ibang GARCH na, guys, no? Hanggang sa dulo. And then on Friday also we discuss vector autoregression at saka yung vector error correction. And that wraps up the term. Okay, so I invite you guys on Friday, 12, 12, I'll start at 12:30. Sana maka-attend kayo. Attendance will not be checked, just like now, wala tayong attendance. No? Okay, so thank you so much.